Hello everyone, welcome to Chem100 with Professor John Nguyen. For the first chapter, this is chapter 1, we'll be discussing measurements, and there's many things out there that we have to measure, and when you measure something, units is definitely needed. If you just say number 5 without any units, it pretty much means nothing. You just know the quantity, but we wouldn't know what we're talking about. Okay, so we got units of measurements, and here's how the few things that we measure. For example, the length in meters, that's the units. That's a popular units. Mass in kilogram, and most of you might know already that's 1 kilogram equal to 1,000 gram. Volumes, the standard units is in cubic meters, sorry. And 1 cubic meters is a lot, it's 1,000 liters. And 1 cubic centimeter is 1 ml. Time is going to be in second, and temperature in Kelvin. And that's the conversions. Kelvin temperature, we got the, take the Celsius plus 273, you got the Kelvin temperature. Okay, so those are just to give you an idea what kind of units we'll be dealing with. Now, scientific notations. Scientific notation is also known as exponent notations, used to conveniently express a very large numbers or very small numbers. Here I give you two examples. When you have a large numbers, especially ending with a lot of zero, if you guys don't want to keep writing too many zero, you can write to the power. If you don't have any decimal place to begin with, you start from all the way from the right, and every number you move, that's one place. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's why you get 10 to the 9. Okay? Imagine if you have a lot of zeros, you can just drop the zeros and have the powers. For example, if you have 5,000, that's 5 and 3 0, you would write 5, 10 to the 3 powers, and you're done. It's so convenient, right? Now, just like this, you have a lot of zero as placeholder. You got, it has to be after the decimal point, so you got 1, 2, 3, 4, 5, and we got to go one more, okay, because the number has to be 1 or greater, but less than 10. And that will give us 6 places, and that's why you got 5.897 10 to minus 6. Now notice that all the zeros gone, and that's the whole point of using negative, using the scientific notations. Okay. And here's the metric prefixes, good for conversions. For example, nano. Number 1 is the base units, and for example, nano means 10 to minus 9, and ask yourself which one's smaller. Obviously it's nano because 10 to minus 9. So if you do 1 nanometers, it's going to be really small, 10 to minus 9 meters, and that's what is set on the scale. Okay, you can also do the other way. Whatever you want to start with 1 meters, because 1 meter is a large quantity. That's why you have to change the exponent to positive instead of negative if you want to swap them, right? Same idea for pico. You can do 10 to minus 12, or you can do 1 meters 10 to plus 12 picometers. Okay, whichever way, they're all correct. That's easy for you. Some of us don't want to deal with negative exponent, then this is a good way for conversions. Okay. Okay, so that's prefixes and units conversions. Now, significant figures and calculations. Significant figures mean important Figures mean numbers. They cannot be omitted or replaced. They are needed, therefore they are significant figures. They need it for what? For quantity and precisions. Okay? And here's are the rules. We got 6 different rules. Non-zero digits are significant, of course, right? Because they're non-zero. The zero between the non-zero are significant. The zero to the left of the first non-zero are not significant. The zero on the right, and also you have to have a decimal point to count them as significant. And if you have a zero, like 5,000, no decimal point, then we're not sure, so we don't count them. Okay? In that case, that's why we have scientific notations. Okay, here's a few examples. You got 25.00. Now, that number 25 is good enough. It tells you we have 25 quantity. However, there's a decimal point, and there's 2 zeros. Because of the decimal point, we count this 0. Not for quantity, for precisions. Okay? So 25.00 is a very serious measurement with 2 decimal places of precisions. That's why it has 4 significant figures. SF stands for significant figures. Now 0.02500 also has 4 significant figures. Now regardless of how it's written, the 0 on the left side never counts. It has to start with a number that's non-zero. Okay? So that's why it has only 4. But 0 on the right, you count them because they follow the non-zero numbers. Now 1.00, same idea as 25.00. You count number 1, you count everything after that because it has a decimal point. That's why it has 3 significant figures. Now here's this, similar to the point, the one on the left. If there's nothing, if they all 0, you don't count them. So you count starting from 8, 9, 7, 3, 5, 0. You do count that last 0 because it follows all these guys, the non-zero numbers. That's why it has 6, 2, 4, 6 significant figures. Now, when you add, subtract, multiply, or divide, they follow different rules, okay? Example is the best way to talk about this. If you got 2.500, that's 4 significant figures, multiplied by 3.0, that's only 2. So you're limited by 2 significant figures. That's why your final answer must have 2 significant figures. You always follow the least one, okay? Whichever is fewest or fewest. Now, when you add or subtract, it's different. You follow the number with fewer decimal places when you add or subtract. So if you add a number with 3 decimal places with a number with 1, let's say if you add these 2 together, this one has 3 decimal places and this one has 1 decimal place. When you add them, you have to round it up to 1 decimal place. So you're limited by the number with the fewest decimal places. Okay? Now for log, it's a little tricky, but we can talk about it later. And here's an example. When we do log calculation for pH. All right. Now I'm going to stop right here, and then we'll continue with the conversion factors in the next video. All right.